It's not actually nice hairstyle. Anyway, good afternoon. Uh, so in the previous session, we were discussing some center of mass of some uniform bodies. I think you have gone through all the videos, all the sessions of previous classes. So now we are going to expand our study. And you need to be pretty much focused in this lecture because here we are going to discuss some things which are going to be a little bit higher of your class 11th standard. So just be prepared of that. Make your mind. So let's start. Let's begin the things and try to be continuous in the lectures. So let's start. The thing is now that we are going to start is case of cavity. What is the case of cavity is first thing is am I audible now? Everything is saying am I completely audible? Just reply one yes so that I will continue. My screen, everything should be visible. Yes, sir. Everything is visible. So now, case of cavity. First thing that we need to know is what is cavity. Okay. So what is the case of cavity? When from a body you put out certain portion from it, like that. Have a look at that. This is a disc actually. You can see that this is a disc on your screen, like this. And what I am trying to do, this portion, this portion from the disc is taken out. And so this remaining portion, so this is the case of cavity. Cavity means some portion is pulled out or removed from a section. So what is the question here? The question here is the find the center of mass of the remaining portion. So remaining portion is this one now. So you need to locate the center of mass of the remaining portion. The first question is that. So now, if I ask you a few questions like this one, suppose this is our x-axis, this is our y-axis, and this is our x-axis, x and y. You all know that by this symmetry, this point, this center point will be the center of mass. Is it clear to you? This is the old thing that we have studied. Now, considering the same diagram, if I say this is our x-axis and this is our y-axis, again, if I ask you about which axis the diagram is symmetrical, x or y, this diagram is symmetrical about which axis, x or y? Can anyone answer in the chat box? Symmetrical means mass distribution is same about which axis. So can you notice that about x-axis, if you look at the upside of x-axis and downside of x-axis, it will look like same. It will look like same. So there is a symmetry about x-axis. So center of mass will also lie on the x-axis only. Center of mass will also lie on the x-axis. This is the first thing that you need to know. Second thing, now what we will do actually, I will introduce a concept of negative mass. What I will do, I am introducing a concept of negative mass. Actually, negative mass is nothing but we can assume this is a trick actually. We can assume that there is a negative mass. So in this hole, in this hole, I am going to put two masses, one of positive mass, and one of identical negative mass. Don't worry, don't think more about the negative mass. You will, this is a general practice, this is a trick actually. So I am going to put two masses, one of plus m, one of minus m. If you just consider plus m mass here, plus m mass here, can you say that this disk will again look like this one if I put a positive mass here? And the negative mass, if I put there, then it will look like that negative mass. Okay. So what I'm telling you, after putting two masses, as soon as I place the positive mass, it completes the disk. Let the complete disk has a mass m1, and this negative mass is m2. This smaller disk has a mass m2, the negative part. M1 is the mass of complete disk. M2 is the mass of that negative mass that we have put here. So there are two bodies now. One is M1, another is M2. Till this point, everything is clear. What we placed two masses, one of positive, one of negative, identical masses. As soon as I put the positive mass, it completes the disk, and let the complete disk has mass m1 and the negative mass is m2. Complete disk has a center of mass at point A that I have told you, and this negative m2 has its center of mass at this point, at its center at B. So can we deal it with two mass system? How can you deal it like that? There is a mass m1, there is a mass minus m2, and the separation between them is this AB. And for two-point mass system, we can easily calculate the center of mass that we have learned. Let this separation is somewhat B. Then center of mass will be, I should choose white pen. Center of mass will be M2D divided by M1 plus M2. But M2 is what? Negative. That's what we can do. Again, I'm repeating, just repeating the things. If you have a cavity, put two masses in it, one of positive, one of negative, identical masses. Positive mass will complete this surface. Negative mass will act as separate body. Now they will become two bodies, and for two bodies, you can easily calculate the center of mass. Let's take an example. This is the basic idea that you need to know. Now, move to a question. Okay. What we were given, they have given me locate center of mass of the remaining portion. You can easily see that what is sigma here? Sigma is the mass density, surface mass density of this disk is given, which is given as sigma. And out of this disk, a small portion of radius A is taken out. Can you see that? A small portion, a small radius A is taken out. This is also radius A. So we need to locate the center of mass. First of all, again, we will decide our x and y axis. So let's say this is our x axis and this is our y axis. This is the most important question in every exam. It's going to be asked, and you need to know the concept. Okay. Now, can you tell me the what is the basic phenomena? I am going to put two masses here, one of plus sigma density, another of minus sigma density. Plus sigma is positive mass, minus sigma is negative mass. Can you see that total mass inside the cavity is still zero? One is plus sigma, one is minus sigma. The total mass is again zero. So no issue with that. Its original system remains. Now, I am assuming M1 is the mass of complete disk. M1 is the mass of complete cavity, or I can say negative mass of the cavity that we have placed there. Okay, so this point A and this point B. A is the center of mass of whole disk. B is the center of mass of the negative disk. Can it be look like that? Mass M1 is placed at A, mass minus M2 is placed at B, and the whole separation between them is what? A. Can you find the center of mass of this point? A is the origin. A is the origin. Second mass is what? M2. This separation is what? A divided by M1 minus M2. Actual formula is M1 plus M2. But M2 is what? M2 is negative in nature. So that's what M1 minus M2. Now what we need to do? We need to calculate these masses M1 and M2 because I have assumed the mass as M1 and M2. So we don't know the values of M1 and M2. So I am going to calculate the values of M1 and M2. So I will look at that. You all know that mass is equals to sigma into area. Are you with me in this? We have learned that sigma is equals to mass over area, then mass will be sigma into area. So M1 will be mass density is sigma. What is the area of the complete disk? What is the area of the disk? This area is pi r square. Pi. What is the radius of this larger disk? Can anyone tell me? Radius of this larger disk. Can you see that this is the center point and this distance is 2a. So radius of the larger disk is 2a. So it will become sigma pi 4a square. This is the mass of the larger disk. Now mass of the smaller disk, this black disk is M2. M2 is what? Sigma into area. Area is what? Pi and its radius is a. So the complete mass is sigma equals to M2 is equals to sigma into pi a square. We will put these values. So XCM is equals to negative is already there. M2 is sigma pi a square. This is what M2 into a divided by M1 minus M2. M1 is, can you see that M1 is sigma into 4 pi a square? M2 is sigma into pi a square. Can you directly write it as sigma into 3 pi a square? The things that are going to be cancelled, you can cancel them. Pi a square, pi a square, sigma, sigma. Is it clear? So x coordinate of center of mass, very good JNV Nasik, minus a by 3. These things are very important. These questions are very important. They can be seen in the exam very easily. I hope you learned the concept here. I will give you one question in homework so that you can practice yourself, practice the things. Is there any doubt in the calculation of masses? If there is no problem, then it's sorted. Okay, moving ahead. This is the question that you can solve in your homework. Again, so this is a square. What is this? This is a square sheet. This is a square sheet, and this portion is taken out from the sheet. Now you need to calculate the center of mass of the remaining portion. Origin is given as O. This is the origin. Now, tell me one thing. This diagram is symmetrical about x-axis or y-axis. Just answer me this one. This diagram is symmetrical about x-axis or y-axis. Answer quick. Someone has answered. JNV Nasik says x-axis. Very good. Very good. It's symmetrical about x-axis. That means center of mass will lie on the x-axis only. There is no need to calculate y coordinate of the center of mass. So it's your homework. Do it in your homework. Now, there is again a simple question. Locate center of mass of the remaining portion. Total mass of square sheet is given as m. This is again a square sheet of side 2 meter and 2 meter. And this 1 meter by 1 meter portion is taken out. Now you need to locate the center of mass of the remaining portion. Again, now I am doing it. First of all, let me draw the x and y axis. So let's say this is our x axis and this is our y axis. Okay. Can anyone tell me about symmetry? About which axis there is symmetry? Can anyone tell me? About which axis there is a symmetry? If you can answer this question, then I will clearly understand that whether you are understanding the things or not. Okay, still waiting. About which axis this diagram has symmetry? You will say, you need to say, sir, it doesn't have symmetry about any of these axes, neither about x-axis nor about y-axis. It doesn't have symmetry. So that means center of mass will have both components. It will have x component, it will have y component. Is it clear to you? These things need to be understood by you. I hope I have cleared the things actually. About x-axis, downside x-axis, there are two masses. Above x-axis, there is only one mass. About y-axis, on the left side, there are again two masses. And on the right side, there is only one mass. This one. This mass is absent now. So there is no symmetry about any axis. So we need to calculate both the coordinates. Now again, what we will do? Can you see the total mass of the this total mass of the square sheet is m? What if I can say that these are the four equal portions? Each portion will have a mass m by 4. Am I right? Each portion will have a mass m by 4. So you can say that this portion, each portion has a mass m by 4. Is it clear to you? Now what we are going to do, we are going to put two masses. We are going to put two masses in this empty portion. One is positive m by 4, another is negative m by 4. As soon as I put positive m by 4 in this cavity, it will complete the square sheet. And this complete square sheet has a mass capital M. And center of mass will be at the center. Is it clear? And this negative mass sheet will have center of mass at its center. This is the center of the negative mass. This small square sheet has a center at this point. Can you see that this center point has some distance? This total distance is 1 meter. This is 1 meter. Then this distance will be 1 by 2. Okay. When we put negative mass along with positive mass, then the total mass will become zero now at this portion. And the actual system given to us also have no mass in this cavity. Cavity means no mass. So there should not be a mass there. So that's why I am putting two masses, one of positive, one of negative, and overall mass of this portion will remain zero. So that my system, my given system does not affect. There is no effect of putting these two masses. Okay, thank you. Okay, so this distance is 1 by 2. This distance is again 1 by 2. What we have done, we have chosen mark the center of mass of two bodies. One body is complete disk, complete square sheet, and another body is smaller disk. So this is the O, this is point I think I can name at O dash. So now we have two bodies. Have a look at that. And don't think that this is a misconception or this is a wrong thing. You are going to use it till 12th. In 12th class, there is again the same concept that is going to be used. So these are two masses. Can anyone tell me the mass placed at O will be? O is the center of mass of complete square sheet, which has a mass capital M. Point O dash has the center of mass of which is smaller m by 4. So that is m by 4. Can you say that this is negative m by 4? Now you need to locate the center of mass of this system. You can easily solve that. XCM is equals to. Have you learned that m1 x1 plus m2 x2 divided by m1 plus m2? This formula is learned by you now. Now I will put the values here. XCM is equals to. This mass is m. Its x coordinate is 0. Second mass is m by 4, negative m by 4. And its x coordinate is what? 1 by 2. Divided by total mass, m minus m by, one is m, another is m by 4 negative. Can you see that these values will come minus m by 8 divided by 3m by 4. 4, 2, 3, 6, m got cancelled. It will be minus 1 by 6. X-axis is 5 by 6. Okay. You are saying x-axis 5 by 6, but you need to answer from the origin, and the origin chosen is this point. This point is the origin now. Origin is O point. So you need to answer from this O point, and from O point, answer is coming as minus 1 by 6 about x-axis. Very good, JNV Akola, by the way. JNV, I think I just misspelled the name. Now, y coordinate will be, again, y coordinate will be m1 y1 plus m2 y2 divided by m1 plus, and you can again put these value, and what you will get again minus 1 by 6. You can check that because there is a symmetry about that, no? So you will get similar answer. minus 1 by. So x coordinate is 1 by 6 minus, y coordinate is 1 by 6 minus, and the answer is in front of you. Again, this is an important question. It will clear your concepts. Now I will move further. Till now, we have learned a lot of things about center of mass. Now the main section of center of mass will start. Till now, we are learning how to locate the center of mass. But now we are going to use some applications of this concept, applications of center of mass. Have a look at that. Today's session is again very important. First of all, recall your concept. This is a basic question and everyone needs to answer. I need answers from every one of you in this. The net force acting on a body is zero. What it says, net force acting on a body is zero. Then what does it mean? The first statement says the body may be at rest. The body may be moving with constant velocity. If it was initially at rest, then it will remain at rest, or all of the above. Which is your answer? Someone answered D. JNV Akola says D. Remaining students, jaldi, quickly, be responsive. Two schools are very active, JNV Akola and JNV Nasik. Very good. Okay. So it's very obvious. When net force on a body is zero, what does it mean? If net force is zero, then it means acceleration is also zero. And if acceleration is zero, there are two things. Either body will remain at rest or body will move with constant velocity. In which state it was, it will remain in that state. That was simple thing. That we all know that. Now we are going to use these things actually. So be ready for that. Okay. Now, I am going to write two or three things here. Position of center of mass, I have told you that position of center of mass is m1 r1 plus m2 r2, or you can add it so on, divided by m1 plus m2 plus so on. Is this thing clear to you? This was the previous relation that we have learned. Now, what if I want to write the velocity of the center of mass? You all know that if we differentiate positions with respect to time, then we will get velocity. So I am going to differentiate this term and I will get velocity. Again, differentiation of position with respect to time is what? Velocity. So I am going to differentiate it. So after differentiation, what I will get? Velocity of center of mass is equals to m1. This differentiation is v1 plus m2 v2 plus so on, divided by m1 plus m2 plus so on. Is this thing clear to you? So sometimes you may be asked to calculate the velocity of the center of mass. So you can easily calculate that as well. Now again, what if I need to write the acceleration of center of mass? Then what you can do? You can differentiate this velocity and you will get acceleration. You can differentiate this velocity and you will get acceleration. So I am differentiating it again. What I will get? Acceleration of center of mass is equals to m1 a1 plus m2 a2 plus so on, divided by m1 plus m2 plus so on. Now, what if I ask, what is this a1? You need to answer that a1 is the acceleration of particle m1. a2 is the acceleration of particle m2. But what is ACM? ACM is the acceleration of center of mass of these particles. There are 10 particles. 10 particles will have one center of mass. Each particle may have different acceleration. but the center of mass will have a single acceleration that is denoted by ACM. Now, now these are the basic things. I have mentioned them as punchlines. Now moving ahead, now I am going to describe some another punchlines. Can you see that M1 A1 is the, do you know the Newton's second law? F is equals to mass into acceleration. Can anyone say that or agree with me that this is what F1, this is what F2, F2 is what force on second particle, F1 plus F2 plus so on. Very good, very good. Divided by, again, everyone will say M1 plus M2 plus so on. Can you write it as total mass? Is it clear now? So if I add forces on every particle, F1 plus F2 plus F3 dot dot dot, so it will become total force. It will become total force. So I am writing is ACM is equals to F net divided by M. Everything sorted till now, na? There is no problem with any lines, any statement here. So can you modify this term like this? F net is equals to total mass into acceleration of center of mass. There is nothing wrong with that. Now, one more thing that I need to add here. F net is what? Total force acting on all the particles. Total force acting on all the particles. But what if I say that we can also write it as F external is equals to mass into acceleration. What is the meaning of external force? External force are the forces which are of not of the system. They are coming from outside the system. Because internal forces going to be cancel out each other, going to cancel each other. So the net force is due to the external forces. So nothing to remember, nothing to worry. What we will learn that F external is equals to mass into acceleration of center of mass. This is what we are going to learn. Now, again, I will move further. These are all the punchlines. So what we have learned, F external is equals to mass into ACM. Now I am saying if net external force on a system is zero. If net external force is zero, you can see from this equation, if F is zero, then A of center of mass, that means acceleration of center of mass will also be zero. Nothing wrong with that. Then what you can conclude that acceleration of center of mass is also zero. And in the recall test, I have told you that if acceleration is zero, it has, there are two things that are going to be happen. One, either body will remain at rest or it will continue to move in the with the uniform velocity. So now there are two things that are going to happen. I will choose another pen. There will be two situations. First situation is if center of mass was at rest, then it will remain at rest. Na? Is the first thing clear to you? What I am saying, if there is no external force and center of mass was initially at rest, then it will remain at rest because there is no external force acting on the system. Second situation that may arise is what if center of mass is moving with constant velocity, then what will happen? It will continue to move with constant velocity. Now, keep these things in mind. What kind of question you are going to face from this point? The questions here will be like that. You will be given a system. Let's start with the question. Now, this thing is clear to you. Now, I don't want to waste your time actually by describing the question again and again. So I think this is clear thing to you. Okay. This equation has another application that we will discuss later. This second point will be discussed later. So let's move further. Now there is a concept test. Okay. Related to this concept that I have told you. Okay. There is a very good question on your screen. First of all, need to describe the question. I'm describing the question to you. This is a smooth surface. This is a smooth surface on which two masses 2m and 3m are placed. And there must be a gravitational force between them now. So due to the gravitational force, they are attracting towards each other. You know about gravity. So gravitational force, due to the gravitational force, they are attracted towards each other. And initially they were at a separation small d. They were at a separation small d and they were released from rest. So this is the situation. I hope this situation is clear to you. Now, what we need to find acceleration of center of mass. We need to find acceleration of center of mass. Second point, velocity of center of mass when separation becomes d by 3. They are coming together. So they were asking the velocity of center of mass when they are at a separation d by 3. Okay. So let's start with the solution. Someone has answered. A has zero acceleration. First part का answer given by JNV Akola is zero acceleration. Very good. How can you say that zero acceleration? By the way, very good. Because you can see that if you take 2m and 3m as a system, very good. Initially, body was at rest, very good. As a system. So can you see that 2m and 3m are the system? So the forces F and F that were indicated by F and F, these forces are internal forces. Do you know the internal forces? When the forces which are internal to the system, acting inside the system, then this is internal forces. So these F and F are internal forces. So there is no external force. F external is zero. So if F external is zero, then acceleration of center of mass will also be zero. This is a very clear-cut concept. Choosing the system, we can decide that acceleration is of center of mass will be zero. Another question. Second part. What does it say? Second part says velocity of center of mass. Now, who is going to answer this question? Second part. Okay, now let me answer. Can you see that initially they were at rest? If initially they were at rest, very good, remain same, very good. If initially they were at rest, that means their center of mass has zero velocity. Now they were released that means and acceleration is zero. F external is zero. So the center of mass will remain at rest. Are you not getting my point? I have told you in the previous slide, if F external is zero, acceleration will be zero. And if center of mass was at rest initially, then it will remain at rest. That means its velocity will remain zero. So whatever may be the separation between these two blocks, the velocity will be zero. Or you can say velocity of center of mass will be zero. This is the more precise term, that velocity of center of mass will be zero. Again, the third question. Third question says, at what distance from A they will collide? At what distance from A they will collide? Now, tell me one thing. There were two masses. This is 2m, this is 3m. The center of mass of this system will be near the 3m mass now. I have told you, na, center of mass will lie towards the heavier mass. So center of mass will be somewhere here at point C. Let's suppose at point C. So what I'm saying, that there is no external force, then this center of mass should remain at the same point. The center of mass should remain at the same point. So what you need to do, you need to locate the center of mass. You need to locate the center of mass. And from which, at what distance from A? So you need to locate the center of mass from A. So you can write x coordinate of center of mass from A is m2d divided by m1 plus m2. Are you getting my point? How I have calculated this? Second mass divided by total mass, that is 3 and 2, 5m, multiplied by the separation between them. So it will become 3, that is 3d by 5. So this is the original position of center of mass, and center of mass should remain at this position. So how it would be possible when these two blocks meet at this point? When these two blocks meet at this point, only then center of mass will remain at this point. So at what distance from A they will meet? You will say 3d by 5 meters. Someone has answered that question. 3d by 5, very good. And answered by JNV Akola. Very good, JNV Akola. You are doing a great job here. So now moving further, there is another question that's coming on your screen. Okay. Again, I am saying that this surface is smooth. The situation says, let me explain the question first. This is a smooth surface on which a plank is placed. Plank is what? A kind of flat surface is placed on a surface. Kind of trolley kind of thing is placed. And a person of mass 50 kg starts walking in this direction, in the positive x direction. So what you need to do, you need to find the distance traveled by the plank when the person reaches the other end. One thing that I am going to ask you, if this person is moving towards right, the common sense, what your common sense says, in which direction the plank will move? In which direction the plank will move? Can anyone answer? Yes, someone has answered. Backward. That means left. Very good. Now, one more thing. If you see that taking man plus plank as a system, there is no external force acting on the system in the x direction. However, gravity will be there, but that gravity is in the y direction. So in the x direction, there is no external force. So the center of mass will remain constant or will remain at rest in the x direction. Will remain at rest in the x direction. So now let's draw something. This plank will move backward. I will draw like that. This is the surface. I think, and this plank has moved, let's suppose, a distance. This was the original position of the plank, and it has moved a distance x towards left. And the person that was initially here is now moved to the other end and now reaches there. So first thing is you need to find the locations, you need to find the distance traveled by these persons and this plank. So you will say, if I say x coordinate of center of mass is given as m1 x1 plus m2 x2 divided by m1 plus m2. You all know that. There is no issue with that. Just try to learn these questions. This is a very important question again. Now, what I am saying, I have done these question, I think, before that 2 kg and 4 kg, two blocks are there. 2 kg is moved towards the center of mass by this distance. Then by what distance 4 kg should be moved? This is the same question, actually. So, how did we calculated that question? We differentiated these equations. We differentiated this equation, and after differentiation, it will look like that dxcm. If I differentiate it with respect to time, then dt will cancel out from the both sides. So it will be dxcm is equals to m1 dx1 plus m2 dx2 divided by m1 plus m. What is the meaning of dxcm? Is the shift in the center of mass. dx1 is the shift in the first mass. dx2 is the shift in the second mass. I think these things need to be clear very, very much clearly. You know these things. Now, putting these values, can you see that the plank is shifted by distance x in the left direction? So I am putting this value. Mass of the plank is 10 kg and it is shifted towards left. I am taking left as minus. Clear? Plus mass of person is 50 kg. Second mass is 50 kg. And it is shifted by what distance? Can you see the distance shifted by the mass, shifted by the person? It was initially here, now here. The total distance was 20. Can you see that this distance moved by the person? And this distance is 20 minus x. This distance is what? 20 minus x. Divided by, you will say total mass is 50 and 10, 60. Sorry. What is the shifting in the center of mass? you will say center of mass is not shifting because there is no external force. So shifting in the center of mass is zero. Can anyone calculate the equation and solve the value of x? Sorry. If I calculate it here, it will be 10x. I am shifting it here is equals to 50 into 2000. I think someone has calculated it. 1000 minus 50x. Someone has answered that is x equals to 25. Okay. Can I say that 60x is equals to 1000? So x is equals to 100 by 6 meter. I think recheck your calculation now, JNV Akula. Can you recheck your calculation? X is equals to 100 by 6 meter in the backward direction. In the backward direction. That's what is the answer. Is this thing clear to you? Let me ask you one thing. Yes, sir. Very good. Now, can you solve one question as a homework for me and promise that you will solve that question actually? This is again a very good question, a very famous question actually. Do it as a homework, and if you face any problem, then you can ask me. I will help you that. I will help you in that. And again, I am saying these are very important questions. It will help you a lot. Okay. I think I need to wrap the class here. And for the another session, the time is up actually. So thank you everyone. So I am just asking a one simple question, whether you are getting what I am teaching you or there is any issue, you can tell me, you can message me here. And if you want, you can send me a message on my personal number as well. Uh, only message me if you need some help. That is, if you have any queries, you can ask, send me there if you face any issue. Thank you. Thank you. Okay. So let's hope for the very good next session. Till then, enjoy, study. Okay. Bye. I will end the session.